this session, let's discuss about a problem called a zero probability error and what is the solution to this. So last class, please refer to the last class where we discussed a problem on NAIVE based theorem and we saw a problem on that. So with regard to that, there can be a problem which is called a zero probability problem. So what is that? Just let's go back. Okay. So let's say for the previous problem, right, this is the test data given. So what is a previous problem? I'll just go back to that. So in the previous problem, this is the training data set which is given. Okay, this is a training data set, right? I have a training data set where I'm supposed to predict whether the student is going to get the job offer or not. So this is a training data set. And suppose the test data for this problem, we did see how we can apply the NAIVE based theorem, right? And suppose the test data is given such that at the end I will get a probability of job offer equal to yes as 0. Then what do you do in that case, right? In NAIVE based, what we learned is we are going to find the probability that this for the student to get the job offer as yes. We are also going to find the probability that is the job for the job offer no. Suppose one of the probability gives us a value 0, then what do you do, right? So let's say this is the test data. This is the test data given, right, where CGPA, whether the student will get the job or not, right? Job offer is where suppose the student is having CGPA greater than equal to 8, interactiveness is yes, practical knowledge is average, communication skills is good. But will he get the job or not? So based upon the Bayes theorem, right, I'm applying the Bayes theorem equation, Bayes equation, where after applying the equation, I have found the probability, likelihood, right? In the last class, we saw how to find a likelihood, right, for each one. So when I apply the equation, I am getting that the students will get the job offer with a probability of 0.0233. Now I will repeat again, for job offer is equal to no. So for the same test data, right, I will for job offer no, when I apply the Bayes equation, I see that one of the term is giving me a 0 value, the probability of CGPA greater than equal to 8 with job offer no. So if the student, the probability that if the student gets a CGPA of greater than equal to 8 but still he is having a job offer no, this likelihood probability is giving me a value 0, and therefore the entire probability is becoming a 0. Right? When such a things happens, because what happens when you are applying NAIVE based theorem for prediction, suppose one of the probabilities or posterior probability is giving us a value 0, then we say that the model fails to predict. Okay, so this is called as a zero probability error. So this problem, why did it happen? Because you can see that for this condition, right, when the attribute is greater than equal to 8 and job offer is equal to no, there are no instances in the table, right? So this problem has arisen because there is no instance in the given training data set for attribute greater than equal to 8 and job offer is equal to no. So because of that, I got a probability of 0. Now what can you do in this case? In this case, the solution is applying a smoothing technique called as Laplacian correction. So what do we do here is, let's say I have some 1000 data instances in my training data set, and if there are 0 instances for particular values of the feature, like just now, right, we saw that when CGPA was greater than equal to 8 and job offer was no, I was having 0 instances. So let's say I have such cases. What we do is, in such a case, we had one instance for each attribute value pair. We just add one more instance to it. Now just adding one instance out of 1000 will not make much of a difference, but still the probability will not become 0. Okay, so let's see how we do this. This is what we call it as Laplacian correction. Suppose this is our original table, right? This is the likelihood probability of CGPA. So likelihood probability of CGPA, what we are observing here is, when CGPA less than 8, here I have 0, right? So what I have done in the second table is I have scaled this to 1000 First thing, this is my given table. Like this table, how I got this first table, table 8.4, you have to refer the previous slide where we did a problem of NAIVE Bayes theorem, right? So there, what we are doing for that table is we are scaling it to 1000. So just multiply everything, or let's say 200 to 1000, right? So this will become 300 by 700, this is 400 by 700, this becomes 0 by 700, this is 100 by 300, 0 by 300, 200 by 300. Okay, so I am scaling the table 8.4 to 1000 in the table 8.11. Now I am going to add one instance. See, there was a problem in the last one, right? I was getting probability as 0. So I am just going to add one instance for each CGPA value pair. So when I add, right, what do I get? So this is my table, right, which was scaled. This is my table 8 where it is scaled. Now for this table I am going to add one instance. How do I add? For everything. For probability of CGPA greater than equal to 9, job offer no, it was 100, I am going to make 101. And for this one, probability of CGPA greater than equal to 8, job offer no, it was 0, I am going to add 1 here. So it has become 1 given 300. Again here, probability of job CGPA less than 8, given job offer no, instead of 200 I am going to make it 201. So you can see that for each of these pairs I have added, for everyone I added 1. So with the scaled values, how many instances now I have? Instead of 1000, now I will have 1003 data instance. So now let's again apply the NAIVE Bayes problem. So for the NAIVE Bayes problem now, instead of having here 7, so my original problem now will change, right? So the last one is probability of CGPA greater than equal to 8, job offer S. So that means this one I am getting 400 by 700, which I put here. Now look at this table and fill this equation. Probability of interactiveness equal to yes. Now that I did not make any change, it remains as it is. The last probability of practical knowledge, this also is 100 by 700, it remains as it is. Probability of communication skills, it remains as 400 by 700 into what is the probability of job offer yes. The probability of job offer S is 700 divided by total instance. My total instance was initially 1000, now it becomes 1003. So what has changed here is this one, 1003. So because I had added 3 instances to it, because I added 3 instances for the same problem, you can see that now I'm getting the probability as 0.02325. Now initially how much did I get before? Before I got for that a value of 0.023, now I got 0.23125. But the problem was here, when I had job offer no, here I was having a value 0. This was actually the reason for the problem. So now this will change. This will be 1. Instead of 0, it has become 1. And here the last one also, instead of 300, it has become 303 divided by 1003. Okay, so I had added one value here to CGPA, and I had my total instances also was from 1000, it has increased to 1003. So now instead of getting a value 0, I am getting a value 0.0007385. So basically Laplacian correction is, through Laplacian correction we are able to solve the zero probability error in the NAIVE Bayes classifier. So that's it about today's session. So in the next session, let's discuss about brute force algorithm. So one thing is, before you study about zero correction error, please refer to my previous lecture on NAIVE Bayes problem. Thank you so much.